Well, good evening from Ohio, and as always, I hope you're having a wonderful morning, day, afternoon, evening, night, depending on your time zone and sleep schedule. PX Lip has joined me again tonight.
Evening all.
There he is. Um, and yeah, so and I just realized he's coming out of the. I am hearing him in the wrong place. That's
Uh-oh.
pretty funny. Uh,
Joys that are technology, right?
Yep. So if there's an echo, somebody needs to let me know. But my computer's decided to put him on my speakers, and I have no idea why.
It's always a fun time.
All right. Well, this has been interesting already. So we'll see what happens. I said hopefully my mic is selective enough that it won't pick up the background, but I can't promise that. So yeah, I am not entirely sure that I know how to fix that.
Yeah, not without killing the stream. We might just be one of those
Yeah,
joys that are technology.
yeah, I'm afraid we're gonna have to live with it. I don't think I think OBS got itself confused somewhere, um, which I can't really do anything with. All right, so we will soldier on here.
I will try not to talk too much.
uh, um, all right, so the just to set the stage a little bit here for what we're going to try to do today, and I'm fair warning, I'm going to go with the full professor mode here. I'm afraid at some point. Um, so in the context of developing LST, the local streaming tool that Pierre Slip and I have been working on and talking about, and by the way, shout out that a lot of the actual coding is happening on his channel. So we try to announce that on Twitter as well. And if you're interested, in kind of the how sausage is made behind the scenes, so to
Mm.
speak.
It's,
That
it's been it's been real sausagey too recently.
yeah, I bet. So so uh, we will uh, we'll keep that the actual coding to his channel, and what we'll do here is sort of look at some of the finished product, maybe put some things together, do some integration, do some testing, those kinds of things. As if you were with us last week, one of the things we're talking about is it's a big piece of any of these types of applications where you're basically assisting a Twitch streamer in interacting with Twitch by providing an extra piece of functionality that isn't part of Twitch's software. We need to find a suitable way to do that in a way that is properly authorized. Where there's proper security, that not just any piece of software can just go in and do things on my behalf on Twitch. And the so we talked last week a little bit about OAuth, which is the standard that Twitch and lots of other places are using. Um, and over the intervening week or so, and I think even talking last week a little bit, uh, this stuff is really complicated, and the complexity is in a weird place. Uh, the the actual protocol, and I'm going to spend some time talking through it and try to point out where the complexities are coming from. The actual protocol, the actual thing we're trying to do, is not that hard, and it's not that hard to understand. The minute you actually try to wrap your head around how this actually works in a real application like the one we're trying to build, all of a sudden things get super complicated. And in
Can
part,
attest to that.
yes, he can attest to that. Um, the uh, the other piece to this is that uh, first of all, OAuth, of course, that deals with security, right? And so the minute you do that, you have to be super careful that you're actually doing everything right, because otherwise you expose people to security breaches. And because these third-party applications can take all sorts of forms, the standard has to be flexible enough to accommodate all of them, and that's where things get complicated. It's not the basic principle. It's what happens when you actually try to deal with all the different variations of what can happen. And so the plan for today is I'm going to spend some time talking about what OAuth is actually trying to do, and then kind of in the context of LST and how it's going to interact with Twitch, and talk about some of those those complexities that come into the standard itself and the various bits and pieces. I'm going to use then I'm going to use a very simple sort of a web-based sandbox that the OAuth organization actually puts out, and it's kind of useful to sort of see, kind of illustrate. It's really more of an illustration of what the process is, and then we'll switch over, and Pierre Kleppe is going to actually take us through a demo he's implemented, right? So that we real code, we can look at what really goes on, and it is the same. It may not be the same code, but it is very similar code to what LST will actually embed ultimately to do its job. So with that introduction, let me get my trusty Jamboard up here, and got my drawing tablet because this is going to take a little bit of work. And so the first obstacle with a standard like this is always terminology. And so there are arguably four actors in this drama, and so we're going to start with. I'm going to sort of interchangeably call this. I'm going to refer to this as the user. And that's not what the standard calls this entity. It calls it the resource owner. And so I'm going to use those two interchangeably and point out from time to time. But when I use the term user, it is the usually human entity that has control over a resource. Think of user. Hopefully, some people still remember Tron, the movie. Think of the user as the user. It is this godlike thing that all programs serve. That's the resource owner. Right? This is me, or someone using software. And obviously, if there's a resource owner, there has to be a resource. And so we're going to go ahead and find ourselves a resource here. I'm going to use this guy. So there is a resource server. Yes, I could use text, but I'm too lazy. So this is the normal interaction, and so for purposes of our illustrations here, this is me, and I have a relationship in this case with Twitch. And by the way, OAuth is used by Twitch. It's used by Google, which I think we've confirmed, by Facebook. I'm pretty sure, although I did not independently confirm this, I'm pretty sure it's being used by places like Dropbox, Evernote. So this resource server is the is the main application, the one I originally signed up for, and the problem is that let me finish the rest of the actors here. So down here is an application like LST that we're developing. Oh, come on! I can do better. Right? In OAuth, an application like LST is referred to as a client,
which isn't awkward at all.
Yeah, and client and user are probably fairly easily mistaken, which is sort of, I really should be using the term resource owner, but that's also sort of awkward, right? So going back to Tron, the client is a program. It is not a user. It is not godlike. It is a program serving the user. I love Tron. Speaking about things that are old, I almost forgot. I am supposed to acknowledge that today is the 27th anniversary of Doom. So very important date. Okay, so the client. That woke somebody up in chat. Hello there. So the client is a program. The user is the user. The problem we're trying to solve here is that there's a perfectly whoops, go away. Oh, you're this guy, aren't you? I know where you're coming from. I'm going to get rid of you. There we go. My tablet just decided I wanted another menu. So as a user, as a Twitch user, I have a relationship with the Twitch server, and Twitch is kind of interesting because I'm both. I interact as a resource owner. I interact with Twitch both as a content creator, like tonight, but also as just a viewer, just a user of their regular, consuming content that they provide on their server. And so, if we're just doing, if I'm just interacting with Twitch, and one of the reasons I like the term user is this triangle here. I mean, I can't directly interact with Twitch, right? I need a front end. I need something that I can use to interact with Twitch. And for just about everything we're using today, that's typically a web browser or maybe an Electron app. But the reason user is not is a good term is in the standard, this standard and others, this triangle here, my browser that I use to talk to Twitch is called the user agent. Okay, so I use my browser, my user agent, to interact with Twitch. Right, so if I go to their site, I can select a broadcaster, a content creator. I can, participate in chat. I can buy stuff, right? I can buy subscriptions. I can buy bits. I can interact with the service in various ways. And of course, that shouldn't happen unless I am actually the authorized user. Right, and so there's sort of a barrier here that locks this service using a username and password, and hopefully a two-factor authentication token. So, public service announcement of anyone watching this either now or on the VODs. If you're only using a username and password on Twitch or any of the other similar service, Dropbox or Evernote, stop right now. Now, if you're watching the stream live, just open another browser tab. But if you're watching the VOD, pause the VOD right now and go fix that. Turn on two-factor authentication. All right, so all that means is that when I present my username and password to the resource server, it will then ask me also for a one-time code. And that code typically then comes from an app that runs on my phone. I use Authy, but there are others. And there are other ways of doing that. But that prevents anyone from using a stolen username and password if they ever get a hold of it. So if you're not doing that, stop right now. Go set that up. No reason not to. It's really easy. And it is super well protected. In particular, when you use a resource server that has financial information in it, right? Which in this case, of course, it does, because I have a credit card or a PayPal link on file with Twitch to be able to buy stuff. Okay, so subject to making sure that we do that we do two-factor, there's kind of a standard way for me to get access to the resource server to Twitch in this case. All good. But it's all or nothing. Right? If I log into Twitch, I have access to everything that my account provides. I can buy stuff. I can participate in chat. If I'm a subscriber somewhere, I'm a subscriber there by virtue of this one login, right? So this one authorization here gives me access to everything. And Twitch does have roles but they're very limited. So PXLip is a moderator on my channel, which means he has some ability to interact with my chat, especially using commands to delete messages or block users and that sort of thing. So it's a very limited amount of access. So it's a good example of having multiple roles and having sort of limited access, right? So I don't want a moderator to be able to buy stuff with my credit card or my PayPal, but they have to be able to, so they're able to do some limited things. Okay, so that gets us to clients like LST. Ultimately, what I want is for LST to have kind of a limited, as I use kind of a different line here. LST is supposed to have a limited ability to interact with the resource server on my behalf. And how do I do that? Right? Years ago, pretty much the only way to do that would have been for me to put my username and password into the client, and basically with full access to the resource server, because that's the only way that a third-party app could act on my behalf. And OAuth, which was just OAuth was developed sort of independently from any sort of standards process to try to create a solution to that problem. And then OAuth 2, which is what we're going to talk about today, was standardized to basically sort of fix some problems and come up with kind of a unified way of doing this. And so OAuth 2 is what we're intending to talk about today. And so what OAuth 2 tries to do is give the client a limited credential that only lasts for a certain amount of time, potentially, and that is restricted to only certain functions, right? And I think we're all used to that from our phones, right? Where especially when you install a new app or use an app, it'll ask you to give it permission to access certain things, right? So it may want access to your photos or to your contact list. And you can choose to grant or deny that. So ideally, like LST is not going to need credit card information, right? It's going to need access to read, find out who subscribed to a channel, or it needs to be able to read and interact with the chat. I mean, there's sort of a list of things we want to be able to do. So how do I solve this particular problem? Well, what I need to do, and this is where things are both simple and then become complicated. So what I need to do and it requires the fourth actor in this drama. So there is one more server here. I'm going to try to be consistent. So we need one more piece. Pixlab, is it authentication or authorization? It's authorization, right? Authorization server.
That sounds correct. I'd have to double check this.
We can always look. So this is the actual standard I've got up on the screen right now. This is and I can make it a bit bigger yet. This is RFC 6749, which, by the way, is 8 years old. So this standard's been around for a while, and it is an authorization server. Yeah.
Mm-hmm. That makes sense.
Whoops.
Yeah, because authentication has to do with really the user interacting with the resource server.
Right.
It authenticates that they are who they say they are.
Right.
And then I am granted authorization to use the resource provided by the resource server.
Yep. So so what happened here when I talked about logging into Twitch, that's the authentication process into Twitch. So the standard then reasonably calls this something else. So this is an authorization server. Right. And so let's start with the sort of the simplified version of what is supposed to happen here. So conceptually, and this is why it's both simple and then becomes really complicated. Conceptually, what we want is for the client. What we want is for the client to go to the user and request that the user access the authorization server. The authorization server is then going to then do a version of the authentication, the user authentication that happens when it would when you normally log in. And then again, very conceptually, if that succeeds, then the authorization server is supposed to hand the client it's called a token. And once that token is received, the client can then use that, attach that token to this request here, and that token then allows the client within the scope, and that's the term used in the standard, within the scope of the token, the resource server will honor requests for resources from the client. And so again, specifically LST, we will use a token when we access the server and tell it that we would like to subscribe to a running event feed of chat messages or subscriptions or whatever else we can get. And we'll also use that token when we basically send a request to Twitch to inject something into the chat, for example. So that's the simple part, right? So conceptually, the client gets the user to tell the authorization server, yes, it's okay for this program to access some resources on my behalf, and the authorization server then hands basically a random string to the client says, if you present this along with your request, I will honor the request. And these tokens can expire, so that they don't live forever. They can be revoked, those kinds of things. Right. So where this gets off the rails really quick when you try to actually figure out how this is going to work, and which is what I struggle with a lot, and what I think to some degree both of us struggle with a lot, is how does it actually work when you try to implement it? Right. So it's all nice and good to say, the client, basically it's sort of in human terminology, it's easy to say, well, the client will ask the user to tell the authorization server to do that. Well, we've got to have mechanisms to do all that stuff, and this is where it gets complicated. Because we need to do all of this through the user agent or a user agent, maybe multiple ones, that the user actually has access to. So there's something that's on their screen that they're actually seeing and working with. So we need to understand that the user who we want to perform some of these functions can really only do that by doing that through a user agent. The other another limitation we have to deal with is that these green lines are right now the standard defines only HTTP as a way to do this. So when we're sending stuff to the request that we send to the authorization server, these have to use things like HTTP GET or HTTP PUT requests. It gets even more tricky because the reply, of course, is meant to return an HTML document, maybe with embedded scripts. And of course it could, and in some cases we take advantage of that, it could return JSON. And it returns a return code. And we have to somehow use those mechanisms to make this back and forth exchange of information work, and that's non-trivial. Obviously, it has to be secure. And then the last point, before I try to sort of go through some of the more detailed examples here, the last piece here is that this guy down here, the client. The client can take a bunch of different forms. Right? So our intention for LST is for it to be an Electron app, so it looks like any other application that's installed on the computer, on the same computer that the client is running the user agent on, presumably, and things like the OBS broadcasting software, what have you. But this client could also be a web-based application, right? So it could be that the client really doesn't. So the client really doesn't exist as a separate app on the user's computer. It is a hosted web page that the user pulls in from a server, or it could be entirely embedded in the user agent itself. And I think that's how you wrote your demo, right?
Yeah.
Okay. So it could be that we have a server-side client that then sends sort of HTML documents back and to the user agent. Or the client could actually be code running directly inside the user agent. All of those things have different security implications of how we actually do these things. All right. So so let's take a look and see how this is supposed to work. And the standard is it's about a 60-odd page standard, so it's not like a trivial read, but it has a really good introduction, a really good overview. Again, the devil is in the detail, and so I'm going to try to go through as much of this as I can, and then we'll work our ways through some of these demos. There are a couple of different mechanisms that have slightly different purposes, right? So the kind of the gold standard in OAuth is something called an authorization code flow. So the idea is that this green sequence here actually doesn't directly result in a token. If this happens, if the client makes a request to the authorization server, the user authorizes it, and then a token comes back, that's referred to as an implicit flow. And I think I'm going to talk about that one first, but it's a little bit easier. The gold standard is for there to be a two-step sequence. One where I make a request, the user authorizes the access. I get an intermediate code back called an authorization code, hence the name. So the client retrieves an intermediate code and then directly reaches back out to the authorization server and exchanges that code for the actual token. That's little bit safer because the token, which is after all what's being used to access the resources, shows up in fewer places that way. And the original thought was that, and the standard talks about public and confidential clients. And remember, I just talked about the fact that a client could be running on a separate server and only basically send HTML to the user agent. If that's the case, then the fact that the actual token never passes through the user agent and only gets sent directly from the authorization server to another server, where it's then securely stored, makes that a little bit cleaner. But
what happens if your client only runs in the web browser?
Right. It is just as possible that I go someplace and I retrieve a big chunk of JSON of JavaScript code, and the entire client runs in my browser. Right? And there are implications for why I would want to not use a and I'm not going to go through all the security arguments. It's kind of a little bit outside my area of expertise, but there are some arguments why having this this authorization, there's not much point in doing this two-step handshake if the user agent is actually just running the browser and all this stuff's exposed to the browser anyway, right? So you sort of streamline things and just grab a token right away. All right, so that's the context that we're building all this stuff in. All right, so now we've got a clean sheet here. So which one do I start with? Let's start with the authorization code sequence. And let's assume for a minute here. I'm just gonna draw now. So let's assume for a minute that I've got the user here and the user with its user agent. I have a client that's running on a separate server. That's what this is. This was designed for. And then I'm not going to worry about the actual resource server now. So over here, I have our authentication server. So keep me honest here, Pixlos. I'm just as likely to screw this up as getting it right. So the idea here is that the user, the resource owner, will
the client will provide a mechanism to initiate the flow.
Right. So
a link, button.
Right. So what I was getting at here is the resource owner, the user, basically accesses the client server through the user agent. So they go to a URL of some sort, and get a page back that has a button or something that says, click here to authorize this client, authorize this application. All right, so that's how the user agent learns where to send the authorization request. And the other part is that, and this is where the demos will come in. The client will embed some information in this request. So the user agent will send that request out next, and that is not just going to be a bare bones request to a website. It's going to contain information in it.
Yeah. We're not necessarily sending the user directly to a login page, for example.
No. We
are sending a request with enough information for the authorization server to identify our client. To basically say, I know what application this is that's making the request. Has this user already provided authorization to that application server? Yes or no?
Yeah,
and then things start branching.
And I think another thing to point out here is there is an out-of-band process that happens between, and I'm going to simplify this, between the authorization server and the mechanism for that happening is actually not defined in the standard, but there's an out-of-band process that happens where the client, actually this is a manual process, right? Where the developer, PXLip in this case, actually goes to a Twitch web form and registers the client. So very important to notice that this does not work if the authorization server does not know about the client application. The client has to be registered. And the process by which that is done is left to the implementation, right? So generally, the developer would register their client with the authorization server through an out-of-band process, not part of the OS standard. One of the super important bits of information that get exchanged there is the client has to expose a URL, and we'll see that referred to as a redirect URL. That's where it expects replies from the authorization server to ultimately come back. And that redirection URL has to be registered with the authorization server as well. All right, so again, when you see that,
then it gets passed with every single request you make.
Right, and so when you see the and these are all bits and pieces that I think we were really struggling to understand until we kind of got a handle on some of this.
Until I wrote an OAuth server.
Right. Yeah. There you go. When we see the redirect URL specified, this isn't an arbitrary URL you can sort of willy-nilly change. It has to be registered with the application, and I have no idea how it can be changed, but it would presumably require some sort of administrative request, re-registration, and it would probably invalidate all the old clients that were using the other redirect URL. So you'd probably register a new client ID or something like that.
You actually, that's not that restrictive. I can add as many redirect URLs as I'd like to.
Oh, that's right. That's right. You can have multiple ones
at will. I think because we'll get into those, there are additional identification mechanisms that the authorization server uses to make sure I'm who I say I am.
So at this point, the user has clicked on a button in that was in the web page that it retrieved from the client. That URL, it contains obviously the address of the authorization server. So so obviously this request's got to go to the right place. But it also contains information like it encodes that redirect URL, the client ID, some other stuff that we'll see when we look through the demos. The authorization server will basically redirect the user to a login page. All right, so the client doesn't see that, because in this case the client code isn't running in the user agent, so it actually does not see that. So the user will get usually their familiar login screen. They will have to provide the two-factor authentication if they've set that up. Have you done that already by now? Yes. Pause right now. Set it up. Then you can resume. So assuming that succeeds, in fact the user gets presented typically with a list that says, here's the client that's requesting access. Here's what they want. They want access to these things. Do you permit that? If you say no, it ends right there. But if you say yes, then if you say yes, we have a problem. This authentication server has a problem, because at this point, that authentication server would like to send an authorization code to the client, but it can't, because all it can do is reply to the user agent. All right, so if this authentication succeeds, there's now an authorization code that the authorization server would like to get to the client, but it can't do that directly. It has to send it back to the user agent and have the user agent make a request to the redirect URL. That will get this access, the authorization token here, authorization code, sorry, here. It will have passed through the user agent of the user, but it will now arrive over here. By the way, all the network transits of all these arrows are HTTPS encrypted, so those are not vulnerable. Well, not vulnerable except to the extent that TLS is vulnerable. All right, so this is one of the things that we really struggle with, I think, at least I did, because and you'll see when we go through both the sandbox and the demo how this is done. But you have to basically force the HTTP protocol into creating this sort of weird, making this sort of weird connection, because the authorization server can only produce a reply, and the reply has to go back to the requesting entity. So this has to travel through the user agent. It gets redirected. Obviously, the client will now present, in addition to retrieving the authorization code, it will also obviously tell the user, thank you for authorizing, you're all set now, whatever. And then of course one other step has to happen, and this can happen directly. Now the client, which we're saying is running as a separate entity, it can now act as a user agent in the HTTP sense. It will now go and present the authorization code and request that be exchanged for a token. And then now the client has the token we talked about, and it can access resources. All right, so this is the authorization code mechanism. This is the one you implemented, right?
Yes.
Okay. So this was originally designed for a case where the client really is a separate entity. In particular, it's this last piece here, I think, that the fact that when we exchange the authorization code for an access token, because that can happen in a super, in a much more secure way, because we don't need to do these crazy redirects, right? It can use a straight request response that is fully encrypted between the client and the authorization server. So the other mechanism that is relatively common is a simplified version of this. So again, we have our authorization server, we have the user agent, and this time the client basically runs inside the user agent. At least that was the intent, right? That was the
this was the band-aid for the problem of clients that run solely in the user agent.
Right.
Because it really is a bit of a band-aid.
Right. So in this case, we start out the same way, right? So we're so of course now the client is the user is running the client, right? They may have loaded the whole thing from a server. It may be a I guess it could be an Electron app running with a WebKit interface. So if that's the case, the user might still see a browser pop up. Sort of depends on the implementation. So in this case, the user's running this thing. They again have a button or something that says authorize this client, authorize this application. So again, when they click that, this request goes out here. It again includes a bunch of additional information that identifies the client. There's really nothing all that different. Just as before, the user sees a login screen. They authenticate to the authorization server. The difference now is that the reply, which again has to tell the user agent, the browser, to redirect somewhere. That's not any different either. This reply now directly has the token in it. So there's no two-step process. It directly has the access token in it. It's a little wonky because again, this is a reply. So this is a redirect. So this client has to either on an external server or on the local machine somehow expose. Let's see what I use for that. Yeah, somehow expose. So there has to be a redirect URL that's actually exposed. Because this reply is going to go to the browser, and the browser's now going to redirect to something. So it has to be able to make a request to something. So it could be inside the JavaScript code. It could be a request that goes out to the server that served the JavaScript in the first place and bounces back. It could be a bunch of different ways. The token, the way it's done, remains in the user agent. It doesn't actually go anywhere else. It doesn't travel with this redirect, so it gets retrieved right in here. So it's an abbreviated process, and one that was deemed sort of appropriate when there wasn't a huge advantage in the two-step process because everything was exposed to the user agent and the user anyway. In the meantime, there have been some additional standards proposed that may make it that in the end will make it more even in this case make it advantageous to do the two-step exchange. But At least in some cases. Probably not when the thing is running inside the browser, but if it's running as a separate application on the same computer, there's probably an advantage to go to this scheme here. Right. So let me get out of professor mode a little bit here. And so I'm going to wrap up my part here by going to this site. Let me make that a little bit bigger. So this is the OAuth. I think it's the association. I guess I'd have to see. You know, I'm not entirely sure what they're called, but it's the OAuth organization that publishes resources for those who wish to implement OAuth 2. They provide this particular sandbox, and it's essentially a walkthrough of how this works. So the very first thing we're going to have to do is, and they do this in one step here, although in reality these will be two completely separate steps. So remember that two things have to exist before OAuth can even be used. I have to have an account with the resource server, and the client has to be registered with the authorization server. So we're going to do that first. All right, and it pops me over to a client registration. I tell it I want to register. This is sort of equivalent to signing up for service, but notice it's doing two separate things at the same time. And by the way, I'm going to do this real quick so I don't forget. And I'm going to move that to where it's not sitting on top of PXLib either. So this is just because we actually need this information in a second. So I'm going to keep this over here. All right, so this sandbox this is one of the reasons why this isn't as it's both useful and also deceiving in some ways, because this particular screen here does two completely different things at the same time. Right, so the client registration would be something that a developer like PXLib would have done at some point when they rolled out their client application. And so they would register an ID for the client and in effect a password. The second two bits down here are things that I would have done as the resource owner at some completely different time in a completely different interface. I provided in this case it's an email and password based login. Right, so these are two things that normally don't happen on the same screen. In fact, I don't think they'll ever happen on the same screen. So this is a little bit deceiving, but so those are the four pieces of information. It's basically the equivalent of a username and password for the client and a username and password for the resource owner, for the user. Notice, by the way, that this site, which is run by the organization that wrote the standard, they use the term user. It doesn't say resource owner account here. Okay, so we've created those 4 bits of information. The credentials for the client. One thing that you're not seeing here that should have happened as well, that they're glossing over, is at this point I should also register the redirect URLs that the client is allowed to use. All right, so I think I can continue here. Now I can go through the step through the process, so the two that we've talked about, authorization code, are authorization code and implicit. I think I'm going to spend some time next week, if I have enough time to read up on it. I think this is called PXE. I believe that's the right pronunciation. I'll verify that. This is an add-on standard that is meant to make the authorization code usable when the client isn't a confidential, protected piece of software. The device code, I'm not going to talk about. It's basically it's an OAuth mechanism used when the client can act on its own without needing authorization from the resource owner.
It's when the client is both the client and the resource owner.
Right. So I'm going to bypass that because that really doesn't apply to most of the things that I'm interested in, that we're interested in for LSD, for example. And OpenID is another layer that's sitting on top of OAuth for basically, I think it's meant to facilitate third-party authentication, like using Google to log into other things.
It's that extra layer. It's not authentication. Authentication is provided by the OAuth concept. It's for identification.
Right.
So I've authenticated who I am, and now the OpenID standard provides that identification back to the application, whereas OAuth has no concept of here's who you authenticated on behalf of.
Oh, that's right. There's once the OAuth sequence is done, the client can access a limited set of resources, but there's no explicit concept of who the owner is.
Exactly. Within the OAuth standard, there is nothing that tells me, the client, who just authorized my application to act. So now typically out of band or secondary things, I can hit an API endpoint and get the email address or the name of the user, no problem. But OpenID provides that in a standardized way.
So I'm going to do a little bit of reading on it, and either next week or week after next. I'm just going to sort of add some more stuff here briefly, just because it's interesting and it kind of ties in here. All right, so let's step through the authorization code bit then. So, and I mean, this is done pretty well for sort of a sandbox, right? And so the piece to look for here is that when I click the authorize button, now of course this is a sandbox; it just goes to the next step in the sandbox. But the client would normally produce this sort of button for the user to click, and this is what's up in this gray box is what would be sent out. We said it's going to obviously have to send the user agent to the authorization server, but it will also provide a set of information. One of them is the fact that we're wanting an authorization code, not an access token. It provides the client ID. It provides the place where the authorization server is supposed to send the user agent that the user is running back to. So this is the way to get the user to reconnect with the client. The scope is what is basically. I think this is going to be resource server specific or service specific, right? But so the scope basically it's an agreement between the user, the resource server, and the client. So what things the client can get access to, right? And so what I would expect as a user is I will be told this is what the client is trying to do. And then there is a little bit of a protection mechanism. There's essentially a code sent by the client that gets returned, and so there's some weird security masquerade. There are basically some ways in which a bad actor could try to masquerade as the client, and so this is supposed to prevent that, at least some forms of that attack. All right, so we're going to go to the next step here. And so now, conceptually, I've accessed the authorization server. The authorization server said, "Oh, this client is not authorized to access resources on behalf of this user." This user is not logged in. There's no cookie. There's no state that shows that the user is already authenticated into the service. So we'll make them do that now. So I'm going to go ahead and copy our credentials and log in. All right, then typically what would happen is you would now get a screen from the authorization server that says, you're about to authorize a client to access some part of your some part of the resources you own. And I noticed there's an inconsistency. The scope that they showed was offline access and photos, but it only lists photos here. So there's a breakdown in the demo. Right, so we're going to approve that. Now I don't want to do not want to save this account. And you can't see this in the address bar because that doesn't enlarge when I enlarge the screen. But it's helpful that they show this here. Right, so the redirect URL basically is a host name and a path. Basically, it says I'm going to go to a particular part in a particular page on a particular server. What the authorization server does is two things. First of all, it has to reply, so it can't just send data to the client. There's no way to do that. So it will tell the user agent the place you're looking for is at this other place. It's called a redirect. So a redirect code will come back, and I think we'll see that in the demo later.
Mm-hmm.
Okay. So the client's user agent will actually get a reply that says, to complete what your user wants to do, go and access this other URL. That particular other URL contains a number of tacked on parameters that are sitting behind the actual path that the URL represents. And in this case, there's the state and there is the actual authorization code. So they're coming back in this redirect. The user agent will see them. It redirects to the client and hands the client this information basically as part of the URL. Again, this state parameter is meant for the client to verify that this is a reply to its request, that it's not being spoofed into something. These two match, so yes, we're going to move forward. So now, because we're doing the authorization code, now the client can contact the authorization server directly. It doesn't need the user to really interact with this. So it builds in this case, a post request. It's just a bit easier to send that in this case. And it specifies that this is a request to exchange an authorization code. It provides its client ID. It in this case, this is a secured exchange between just the client and the authorization server. So it makes sense for the client to provide its credentials. So there's some security built in here, where the client identifies itself. Again, that it can't be spoofed by a malicious client. There's again a redirect, and the actual authorization code we got. Right, so we're going to send that off, and by the way, there is a redirect URI here that is not used to actually redirect anything, because in this case, the authorization server can directly reply to the client, right? But it is used as an additional verification that this is the correct client, and that just matches the client credentials in the database. And so the authorization server replies straight back to the client with a JSON, basically a JSON object that contains basically information about the token. Right, and so Bearer is a particular type of token. It's valid for a certain amount of time. The token itself is basically a long string that can't. The only requirement from the standard is that it has to be very difficult to randomly build an access token that will actually be valid. Right, so this is not a random number. There's some stuff encoded in it. There's the scope we requested, and because the token expires, there's a mechanism for asking for a new token without having to go back and getting a new authorization code, which would have required the user to interact with the service again. All right, so that's the long version, right? And so before I hand this over to PXLib, we're going to go through the shorter version. So if the client is running inside the browser and we really just want to do this as quickly as possible, we use this implicit flow. All right, the first part is the same. I basically create a button that the user will click. It goes to the authorization server, and now the response that I'm asking for is I want a token. I don't want an authorization code. Still send the client ID, send the redirect URL, which in this case really is where I want the authorization server to redirect the browser to. So this is where it came from. And this one, they only request photos, not offline access, and that's why the other screen wasn't right. And it still has a state to prevent, sort of basically injection of malicious stuff. All right, so I need to, again, I'm going to get redirected to the services login. So I need to grab that. All right, and so again, I get the user agent, the browser the user is running, gets a reply back that says, "We found what you're looking for, but it's not here. You have to go to this other URL." And that other URL again has the server name, the path in it, and this time it has what's called the URI fragment attached to it. And normally this is meant for a browser to retrieve a document like an HTML. This goes way back into the original HTML and HTTP documentation standard. The intent originally was the browser would go retrieve a document, and this hash mark and whatever followed it would give the browser a clue as to where on the page to scroll. So it was a way for the user to be directed to some portion of what could have been maybe a very long page. In this case, this is where we stash the token. There is a token type. There is an expiration. There's a scope. There's that state coming back. There is no way to renew one of these. It wouldn't make any sense because we didn't ask for an authorization code anyway. So it doesn't, there's no difference in actually getting a new token versus renewing it. So in this case, there's no renewal possible. One of the reasons for switching to this URI fragment is, remember, this comes back as a command to the web browser to say, go and retrieve this other document. right? Because the web browser thought it had, it sent a request that was when I, in this case, when I clicked authorize. When I as a user had finished my login, the browser thought it had sent a request. It expects a document back, but there's no document. Instead, what it gets is go to this other place to get the document you're looking for. And that, of course, could be on a server. It could be local, but it could be on a server somewhere that simply retrieves the client code again for me, or some portion of the client code. And the advantage of this URI fragment is that it does not make that round trip, right? Because the browser is going to make the request without anything that's following the hash mark, because it knows it's going to get a document back, and then it would normally use that to scroll to some part of that document. So this stays in the browser. You retrieve the client code. The client code can retrieve that piece of the URL, but it doesn't make you don't have something that is a secret, make an unnecessary round trip through the network. All right, so we'll again make sure that there was nothing nefarious going on. The state is actually what we sent, so we can continue. And so now there's nothing. Now the client code can pull all the information we need out of the URL that it got. Right. So notice that we spent well over an hour going through what on my initial slide here was basically two green lines drawn on a diagram, right? And I think that's what Pierre Slip and I kind of struggled with over the past week or two, is that this all looks simple until you try to actually implement it, right? So with this, Pierre Slip, if you're ready, I'm going to switch to your screen right there. And so we'll let you take over and kind of explain what we're seeing here.
Yeah, so I've stripped off a lot of the extra bits and pieces. So I'll show some of the code in a minute, but we'll walk through the flow briefly. So this is the full authorization code grant flow. Essentially, where I've ended up is, and we'll do this really fast, is where the user would end up to log into your app to the resource server.
So how did you get to that one? Yeah.
So this is just part of the application. So it's nothing special. This is just manually created. I have a little link for myself that just that attaches all of the parameters that I need to it. So ideally, right, this application would have a button on a different page that would send me here.
Yeah.
But consider it's all on one page. This link could be somewhere else.
Yeah.
So like you saw earlier, right, I've got my client ID. I'm cheating. It's literally just a redirect URI that's going to send it where it's going to send me back to, and then my state parameter. And
so what are we looking at here? Is that
this is the URL. So this is the URL that I was currently on here.
Okay, so that contains all the parameters that like we saw them
exactly.
earlier.
And so just sort of like you mentioned, the client ID is just my identifier as an application. The redirect URI is, hey, I want to, this is where I need to this is where I need you to send the user back to when you're done. What I want back in this case, right, the authorization code, and then they call this one's opaque to the process. It just basically gets sent back to me at the end, and it's just oftentimes people will hash some of the parameters that get sent out or something like that. It's a sanity check to make sure that I'm not getting a malicious URL back out. So I will show really fast so we have a really straightforward, and this is old school JS too. I borrowed this from some examples online. We have a really old school, basically it's in code. There's my username. There's a very creative password. So I will log in with that, and I have unfortunately, I don't think, no, I can't, good. I have the network console up here, so you'll see this is the initial request. So I got into index.html. It's where I want to be. I pulled in some JavaScript, not shocking. So now I'm going to submit, and you'll see. So it's, excuse me. So I got that 304, right? In this case, it's a not modified. So let me do this again, actually, because that way we'll get this properly. There we go. So I got it authorized, and I got a 302. So in HTTP speak, 302 says, hey, what you're looking for is not here. The princess is in another castle, right? Go here, and you'll see that's the URL I'm actually at right now. Those two, you can't actually read the URL up here. So let me do this. So this is the URL I got sent back to.
localhost 3000 is your redirect. Oh, there we go. There you have it up
Yep.
there, right?
Yep.
So the redirect URI is localhost colon 3000, which if you haven't seen those, that's a port number. Slash response.html. So that's the full URI, and the standard does not permit anyone to register something that has either a query or a hash parameter behind it. It has to end on a path like this.
Yeah, which makes which was one of the tricks I had to deal with the Electron-based application, because you can't use HTML5 based routing in a front-end Electron application. So typically you use hash-based routing, but if you're using hash-based routing, you have problems with dealing with a response code.
Yeah,
So
because
there was some fun
you can't
can't
register
mix those
those.
two. So you'll see I got sent back to my redirect URI with, like you mentioned, some query parameters. In this case, I've got code and I've got my state back.
Mm-hmm.
Now I don't do any of this, any of the extra sanity checking, right? So this is the response code that gets turned into an HTML file, and literally when I get in, all I do is, excuse me, I grab the URL and I pull out the search parameters, and I assign them to a local variable. That's it. Nothing special. But what I've got now, assuming it's still active, so now I've got an authorization code, and like you saw in the other demo, right? I can now request a token, and so you'll see I made
And normally the get token would not be a
you
user
wouldn't see
clickable
it.
thing. You
Yeah,
wouldn't see it. It would just happen.
yeah. This was just so right. This would happen. That would happen automatically, right?
Right.
Part of getting sent back with the response, as soon as I had it, the server would go, hey, cool, I've got the authorization code, let me send it to the let me go request a token from the endpoint. It's just in this case, since everything's running in the same place, right? So
Yeah.
back into the network, this time I got a 200, which in this case means you defeated Bowser, you found the princess, and yeah, I mean, in this case, it's right. It's sent back this is its body, so I can look in there. There's the body of the content, token type, expiration, access, and refresh.
So was this a JSON
Yeah, so you can see
a
there's
form
the raw
encoded?
response.
Oh yeah. Okay.
The preview just
Yeah.
gives us a nice little clean way to
Yeah.
look at it.
Cool.
So that was building that out. So sort of because it's worth talking through, this is building out these servers is obviously a lot more fun than it sounds. Even using the there's so this is a basic Express app, and Express is just I think we mentioned it briefly before. It's a simple Node server that just handles, abstracts away some of the things that are annoying to have to do all the time. I could do all of this without Express, but it's just a little bit simpler to do it this way. Even with that, you'll see this turned into a relatively long entry file for something where I've been provided what calls itself an automated OAuth server.
Mm. So this is so we're looking at the server end right now.
Yes, this is the server file along with these two files essentially make up my server. So in server.js, right? So I had to implement a number of functions to make all of this work, basically around storing and retrieving access tokens, refresh tokens, identifying clients based on IDs and secrets. And you'll see I've been very lazy in a lot of places. I I don't bother verifying secrets ever. What do I do when I get an authorization code? I need to save it. How do I get the authorization code back? So this is all theoretically stuff that would be wired into a database or a data store of some sort.
And so the authorization code came back in the query parameters of the
Correct.
redirect
Yes. So we can.
redirect. So you
Yep.
had
So
to
we can.
snag that out of there somehow in your code, right?
Yes. So yep, I can show you that. So this is the yep. So there's the actual request URL, and you'll see the code in there.
Right.
Actually, I've got two of them, so that's fine. And in my code, this is the front end file. It's a Vue. I like Vue for my front end framework. Right here. So window.location is basically it's the URL of the browser is currently at. I converted it into a URL object. This is defined by the JavaScript standard, and just gives me some access to some useful parameters. So the URL.search
Oh, and then you
params.
just grab the search parameters, which of
Right.
course
So
is the
then when I have a little button that's right here, when I click on it, test token, that's my
right,
click to, or I'm sorry, get token. Apologies,
right.
I'm getting ahead of myself. Get token, it then builds the body of the request. There, I'm getting the code out of the search params. Obviously, right. So this is where the implicit grant comes in, right? Because currently I'm storing my client secret. And obviously, if I'm doing that in a public web browser, in a public browser-based application, it's not great.
Yeah.
Right? It means that I'm going to be swapping my secrets out a lot because, well, because it's going to get someone's going to steal it, right? And they're going to pretend to be me a lot, and it's going to get messy.
Yeah, so
So that's
there's really no protection against. So this is
nope.
you know the uh, the user would still have to authorize, but
Yes, I
but
think
they
the goal tends to be because they have it, they can. There's some theoretical nastiness that could probably go
yeah
on, particularly if you manage to insert a man in the middle, stuff like that. That's
yeah.
I think where it probably gets more
Well, so
dangerous.
I think that's one of the things we're going to talk. I'm at least I'm going to try to talk a little about next week. Uh, because that's where Pixie comes in, trying to prevent some of the shenanigans. So I'm going to take a look. I'm going to do a little more research into what the threats are. But this is obviously one of them, right?
Yep.
The because that's required. I need to take a look at the standard again. I don't know if that's a shell or a must, but I think
The client secret is a must for authorization code flow.
that's what I thought. Because
It is a required
yeah.
portion of getting a token back.
Yeah. Yep. So of course, so there's no really good place to stash that secret if it has to embed in the code like that.
Evening, ODG. How's it going? A nice raid from Old Depressed Gamer.
Ah, good evening, ODG. Welcome, welcome.
Apparently my command did not work today.
It's the bot acting up on us. I was able to use it
Apparently.
earlier.
Yeah, you should say it worked earlier. I don't know if it's
Yeah. Oh well. Well, I'll try it again in a minute. I've had Nightbot just basically check out and
yeah,
not do
oh,
things the way we wanted them to.
good times. That's part of why LST is sort of an interesting conversation because it provides you sort of a degree of bot functionality that you have much more control
All
over, which
over than
is
that, yeah.
it's intriguing.
Yep.
So yeah, so that was, I mean, like I think I said earlier, we would say it's a pretty fast little demo, but it's kind of neat to be able to actually see the flow and actually having to script
So
the flow.
so uh,
So
so
let's
you show yeah. I was gonna say can we can probably also see where you get the access token out of in your code.
yeah, absolutely. Let me just walk through. I can walk through that code again. So I'm going to clear the log. So I'm hitting the endpoint /authorize, right? And so part of what is fun, right? So you'll see this request has lost all of the initial stuff, right? The client ID, the redirect URI. So part of what the authorization server gets to deal with is the joys of storing that data for later use. So in this case, I grabbed it, I dumped it in a session secret. You could probably stick it in hidden form parameters, and I wouldn't be surprised if that's what a lot of people do. But when I hit /authorize, so that's the endpoint URL, right, that I said. Sorry, actually, I'm trying to skip past. There we go. So on any given request, right? So when I hit that /index.html, that login page, I check for any of the OAuth parameters that I need, and I dump them into the session for later use. So I'm right here, just to make sure that I have them when I then proceed to hit this point. So you'll see this is a little middleware function. It pulls out and attaches those required parameters to the body of the request. So now this piece is a little bit buried, and I can pull it up here. So authorize handler is a pretty long little hunk of code. Again, really old school JavaScript. I find very interesting. You can see it has a lot of rules that you have to hit. So if the way I'm handling it doesn't implement the correct methods, if this isn't set, now this has a default, so it doesn't matter. If I haven't set how I store my data, if it hasn't set the get client method or the save authorization code on my model, all of those pieces can kick you. If all of that works, it sets some stuff and then handles the request. So here, even more things that can go wrong. So it'll reject if the user denied access. Basically, if I somewhere along the lines, and I don't have a path to achieve this, but if somewhere along the lines the user hit cancel, I would set this, and it would send back an access denied redirect response. And so my application would know that, hey, the user said nope. And then from here, it just does a number of things. So it pulls up some data, gets which client is making the request, which user is authorizing the request, and then it runs those all essentially in parallel. So this is a construct there's a lot of trickiness here to get to sort of understand exactly what's happening. But basically, pretend that all three of these were run in parallel, and then when they're all done, it calls this method with the results of those functions. So expires at comes from authorization code lifetime, client, get client, user, get user, so on and so forth. And then it does a whole bunch more stuff until it actually generates an authorization code, which in this case I didn't override, so it just generates essentially a 40 character random string, which is fun. So those are sort of the pieces. It eventually builds builds a response, builds a redirect URI, and then updates the response before which actually this piece is where the response gets sent back to the user.
And this is with the authorization code.
Right, so the authorization code is attached to the redirect URI here, right? So it builds a success URL. I can probably, no, it's not finding that. That's fine. That's buried in another piece of code probably. Actually, I bet you it's just that it doesn't like yeah, here it is. Of course, that doesn't help me at all because it just shows me this, but that it does attach in this process. It does attach the authorization code. So that's what builds
Right. So that
this URL
attaches the query and
and the state.
the string behind it. Yeah.
Yep. So then I roll around and I can hit get token, and that gets done in the token handler, which similarly has a whole bunch of errors that can go wrong if I've forgotten to forgotten to implement any of the methods, if I've forgotten to include any of and you're not even seeing here, there are a number of, every request has to have the correct parameters on it, the redirect URI, the client ID, the client secret, the in this case the access code, the request type. I said that one caught me. And it doesn't, of course, it doesn't easily list which request types go with which request. You have to go dig up that information manually.
Yeah.
Which is always fun. So, and again, so we just, we're binding promises. So basically this is a sequential chain of promises that will execute, wait, and then do the next one. But here I generate, so I've generated a token model here that it gets, again, we attach to the success response, and that's what gets sent back to the user.
But this one gets attached as a fragment, not
No, because this is an authorization code grant.
Oh no,
body.
this is the JSON. This is the JSON file that comes back.
Yeah. So if I look, if I pull up,
well, that's right. This is not implicit. This is the authorization code.
This is the full authorization code grant type. Sorry, you'll have to forgive me.
And as you're searching, ODG, we're kind of near the end of our stream here as well, and that if you rewatch the VOD, I spent quite a bit of time drawing on my Jamboard, trying to lay out what all this is doing. But what we're basically going through is are the details of actually authorizing an application like the streamer application to use Twitch in a general way. So this would basically replace obviously replace, like in your overlay you have a token. You basically generate a token at manually and embed it in the API requests, and this is the automated way to get a user to authorize an application to do that.
Sorry, I'm trying to track down where it is.
Somewhere in this code we're doing that.
This, right? It's like, oh, nope. I found it earlier today, and I meant to leave it up, and apparently I did not do that. So you'll forgive me. I'm digging, trying to remember where I ran into it. The problem is sometimes I forget which file I was in when I was looking at something.
Yeah.
Especially when I...
no doubt. Yeah, ODG, you really are running late tonight. It's some ungodly hour of the morning, and you're where you are.
I want to say it's here. Yeah, following the code paths in this code too is a real challenge.
So this is a mix of stuff you've written and stuff you got from that OAuth server open source project, right?
Yeah, this is the most of the code we've been looking at is the OAuth 2 server implementation by the OAuth standards group. That is horribly documented and impossible to understand without actually just doing it. So, it's good times. Spread. It's got to be in here.
Yeah, so this stuff has got to build that little JSON, the little JSON object somewhere, right? That's
Yeah,
yeah,
there we go. Yeah, so it's wrong piece. So this is the layer on top of it that makes it express middleware. Oops, that's not what I wanted to do. So this is, if I come back to my code, so you'll see when at the /token endpoint, I call this OAuth.token. And OAuth is the little piece of middleware that gets stuck in there, and I hand it a little bit of information about what I'm doing. So here's that method that gets called. It returns a function that returns a promise. Just a
yeah,
mouthful if you've ever
yeah.
seen one. Um, but then it is
JavaScript at its finest.
essentially it is essentially a facade wrapping around the OAuth 2 server that's actually generated by oh yeah, Nightbot was running slow. That's fun. We just got the second Nightbot notification. Good times. So the server is actually the OAuth 2 server that's running um, that's doing the actual work. So we grab the token data from it, which then calls this sort of cascades to this next step. I basically just attach it to the method, and then it calls the handle response. So this is again a JavaScript construct, basically, so that I can provide the context object to a method. So in this case, I provide a context object to handle response. There are much better ways to do this that have a lot less redirection, but this was all written several years ago before it was popular. So here's where the actual stuff gets sent. So if here's the 302, so that's the redirection we were talking about when it's sending back the access code or the authorization code. So it grabs the location and sets a response header that says, hey, go here, and then tells the browser that redirects. If it's not the 302 redirect, if it's a token or a refresh token or a refresh request, it just sets some additional headers. In this case, there's nothing too crazy. It sets like a making sure that your browser doesn't really cache the response. It sets an e-tag. It's primarily around caching and rules like that. But then the important part is it sets a status, says, hey, we got through 200 or something else, and then here response.body, their response in the process, the body of this value has been set as a JSON object that is the token object that we
Yeah.
want. So
Yep.
that is the endpoint that actually deals with it.
Cool. All right. So, as I said that at the very beginning, this starts with a relatively simple diagram on a napkin saying here's what's going to happen, and ends in fairly complex implementation.
To call it spaghetti would be an understatement.
So, I guess before we wrap up here, so a question for you as far with respect to how this pertains to LST ultimately. So I think if you have the time to clean things up a little bit, I think we talked about maybe making this demo available as an open source.
Yeah.
But in terms of LST, so there's a are you are you able to reuse the client code that you produced for this?
Not really. To
Or
some degree,
you
yes.
you can learn from it. What's the
Learned from it is a good way to describe it. So the part that you really have to that is tricky to wrap your head around, at least was for me, was just thinking about separating out what happens where and to whom. Right. So the initial request out that gives the user the option to authorize my application versus the redirect response back in, right? Handling those separately and determining, okay, I need an endpoint that can get called back. Here's the content that is going to come with that. It's going to be in a fragment or in the query parameters. Okay, cool. I have a piece of information that that I can either use or that I need to then exchange for this access code. So it was for me at least, what this really provided was an opportunity to really look at each piece independently, write code that handled it, instead of sort of looking at the end goal, which was to, I want authorization to access Twitch's APIs on my own, in this case, behalf, but on someone's behalf. It forced me to sort of really come back and say, okay, abstract, in the abstract, what does it take to get an access token?
Yeah. Well, the actually not so much in the abstract, right? I mean, the abstract is sort of
Mm.
simple, but I think I think the what we what we found out is that the um, the implementation details get thorny really quickly.
They're
Even though
very
this,
precise.
you look at the diagram in the standard, and it's relatively straightforward. But then you try to actually build something that uses it, and it gets more like you said, it gets more convoluted than the standard will lead you to believe
Hmm.
when you first start, right?
Yeah.
So we'll talk a little about what. So you have a just sort of a guess as to what we do next. Or what are your next steps for LST? Are you going to try to build the OAuth part, or are you going to
Yep.
switch to something
Yeah.
else first? Or
No, I think a plan is to actually implement the authorization flow with Twitch, probably do proper authorization code grant. So figure out how to proper safely. Microsoft did it, I can do it. But figure out how to properly store the client secret in the application in a way that is as secure as possible.
yeah,
Um, and then from there, actually walk through the flow and write the client code that's required to get an access token back, so I can access. Because from there, right, I really, to do anything else, that I need that. I think the only other thing, the step after that is probably to spin up a fake WebSocket server, so we can test out, that basically looks like OBS WebSockets, so we can test out some of the interactions there before we try it against the
before
live OBS.
before we've actually, well, and at this point we're both using OBS, right? Because
Mm-hmm.
you're. By
Yep.
the way, I I don't know if ODG had to basically go to bed by now, but if you haven't, ODG, thanks for your input last week. We did do some sleuthing around the display of PXLib's screen, and we were doing we were scaling his screen by a non-integer factor. The aspect ratio wasn't being messed around with, but going through all the different steps, we finally figured out that we were stretching. We were scaling his screen up, I think, by like something like 1.337 or whatever it was, which will create some really fuzzy letters really quick. So. How are you set? So now you're set up with an OBS scene, and you're using OBS as a camera to
Yeah.
go into WebRTC, right?
Exactly. Yep. So I'm using WebRTC to grab the OBS virtual camera
Yeah,
in addition to my own camera.
yeah. And we're both now relying on OBS for the for the live part of this. So
Yep.
so
Makes things exciting.
neither of us really want to experiment on
Yeah.
OBS
Yeah.
while we're live. So yeah, so that's a good point. We'll have to
Yeah. So
test
no,
that out off stream.
yeah. So I will build out a for any work we want to do on stream that requires it. I'll figure I'll build out basically a fake WebSocket server that just responds with dummy data.
Yeah. And then we'll show it off when it works, and we've actually tested it, and we know it's not going to crash OBS normally.
Normally, I'm sure at least one of the times we'll crash the stream.
No, that's a good point. ODG was just saying we could run a second copy of OBS.
You mentioned that. I was curious if there's a way to put OBS in like a portable mode so that I can have a second instance
Right.
running.
That said, those I don't know. Did you configure the WebSocket port? Is otherwise that wouldn't work, right? I mean, it doesn't matter what they're running as. There's only one a
Well,
port.
so long as I only have OBS web server installed once.
Yeah, true. Yeah. That's true. That is true.
Yeah, we could do it on a VM. We'll see.
That's
Lots of options.
that's the other option. We could run that in a VM of some sort. So I think we're about to wrap up here. I think. Anything else from your end?
No,
I was just checking. We probably need to just kill time for a couple more minutes. I noticed Resurrection Fern is she was supposed to start the same time we were.
She's about to start, isn't she?
She just
2
went.
hours late?
She just went
Sounds about
live,
right.
but she's still on her "I'm not quite live yet" screen. Her countdown has ended, but she's on her I'm not quite.
I'm happy to kill air until Fern hops on.
Yeah, I've got it. I've got her on. I've got her on another browser window here, and I think once she actually comes online, we'll go raid her. We'll take ODG with us. At least be three of us.
Let's just see. Let's see if the internet will tell us about running. You can watch me.
Do all sorts of crazy stuff, huh?
Yep, you can do it. I think. I'm intrigued what will happen when I try to run the second instance.
Yeah, you might not want to try to do that right now, but
Oh goodness, no! I will try that. I will try that some other day. But it's a good point. I'd forgotten you can put OBS into portable mode. Basically carry it around on a thumb drive for it with yourself. But
right.
it'll be an interesting experiment.
That might just work.
It'll be a fun attempt.
Yeah, but yeah. So I mean, this yeah, ODG just said end of stream is a bad time to test OBS to say goodbye in case you crash it. Yeah, we'll try not to do that. But
let's see what happens here.
But OAuth is OAuth. I just so we're just obviously we're just sort of killing time here. Look at that! She's actually on screen, sitting on the couch. All right, folks. So so we are going to hop over and raid Resurrection Fern, who's a wonderful singer-songwriter on Twitch, who just moved and is setting up her new stream room. So talking about OBS, I'm sure that was part of her delay. But yeah, so I'm going to switch us to our outro screen here in just a sec, and then we will raid Resurrection Fern, and hopefully we'll see everybody again next week. Thanks for being here, and have a good night.